Hello everyone, welcome to the online course on manufacturing processes. I am Kishore, Assistant Professor in the Department of Mechanical Engineering, MLR Institute of Technology. We are discussing this course before. Already we have discussed casting completely. We have completed casting. Now we are going on the second chapter of this course, that is welding. But before coming to the welding, we'll start with the manufacturing processes classification. We'll see few examples and then we'll relate those with the welding and then proceed in welding. So we'll start with the manufacturing processes, its introduction, and of course its classification, broad classification. Then we'll see how broadly joining processes are being classified, and after that we'll come to specifically for the welding, which is there in our syllabus for the second year. And the last we'll see types of welds. For today's lecture, these four topics we are going to discuss: manufacturing processes, introduction and classification, of course, and then broadly classification of the joining processes, then classification of welding, and at the last we'll see the type of the welds. Okay, so manufacturing processes, in our first lecture, if you remember, already we have discussed how broadly it is being classified. So this is broadly classified actually in four parts or four types. First one is casting process, second one is forming operation, third one is machining process, and fourth one is joining processes. Also we have seen this, we have already completed, and we have seen that in this process, to transform the material shape or the dimension, we need to melt the material. So first we'll melt the material, and then a predetermined dimension mold will be there. In that we'll pour that molten material. Once it will reach over there, we'll leave it for some time, sufficient time, so that it will solidify over there, and after complete solidification we'll take it out. So whatever the shape we want or whatever the dimension of the specimen or the job we want, we'll get from this one. So in this one we have to melt the material to convert in a particular shape. Second one is forming. Here we don't have to melt the material. What we do, different type of forces we'll use, and by applying the forces we'll change the dimension. So material will come at its plastic state, or whether we are doing at its room temperature, I mean cold working, or it is a hot working. Depending upon that, we'll apply the forces. Different kind of forces can be applied, and then we'll change the dimension of the specimen. For example, this stylus is by hand. Suppose I have to increase the length of this stylus. What I will do, from both sides I will pull this specimen, means tensile force I have to apply in this one. So what will happen, its length will increase and its cross sectional area will decrease. So depending upon the application, what is the application, what we want actually, what kind of dimension we want to change in the material, accordingly we have to choose the forces. Okay, now so different kind of forces can be applied depending upon the application. If we have to increase the length of this stylus, then we'll apply the tensile force and its length will increase. But to compensate that one, we know its cross sectional area will decrease. Similarly, if I have to change some other dimension of the material, suppose we have to shear off the material from the top surface, we'll apply the shear force. So different forces or combination of different forces can be used to change the dimension or the shape of the material. So it may be a tensile force, it may be a compressive force. Suppose I have to increase the cross sectional area and I have to reduce the length of this stylus. So what I will do, I will apply compressive force from both sides. So what will happen, length will decrease and of course its cross sectional area will increase. So what I mean to say, that a different kind of force or combination of different forces can be applied depending upon the requirement. So it may be a tensile force, it may be a compressive force, it may be shear force, it may be twisting force. So what we are doing, we are applying different kind of forces to change the shape and size of the specimen. We are not melting the material, we are not going to join the material. Those kind of things we are not going to do here simply. So it has actually two parts. It may be a sheet metal forming, it may be bulk metal forming, or so depending upon the material thickness, these two divisions are there. Okay, so it may be sheet metal forming, forging is example, extrusion example of this metal forming operation. Extrusion is there, forging is there, many other processes are there that we can be considered. Wire drawing is there, then we have pipe drawing or deep drawing. So all these processes come into this category. Then we have the third one, which is known as machining process. Machining process means we have to remove the excess material to bring it in a particular dimension. Suppose this is a stylus I have to prepare, and we want its diameter to be 10 mm. And if this material we prepared by some manufacturing process, primary manufacturing process, and suppose dimension is 10.5 mm, its diameter is 10.5. So that excess 0.5 mm diameter will remove through machining operation. So this is the third manufacturing process. Here we remove the excess material, and that is the definition of the machining also. Removal of excess material from whatever the specimen we are going to change the dimension. So this will be the third one, that is machining. This is not in this syllabus, it will be in the next semester. Today what we are going to discuss, this is the fourth manufacturing process, which is joining operation. Means we have to join two or more than two a specimen together. So different techniques are there, different methods are there through which we can do. So in joining also, it actually of two types. It may be permanent joining, or it may be temporary joining or semi-temporary. Okay, so permanent and temporary means, permanent means suppose we have joined to a specimen. So if we have to dismantle these two parts, we'll have to physically damage the same. This is known as permanent joining. If temporary joining is there, means simply we can dismantle the parts. So broadly, if we'll divide these two joining processes, so it will divide into two parts. It may be permanent joining, it may be semi-permanent joining, or it may be temporary joining, depending upon whether we have to physically damage the sample or not. Depending upon that, its further division will be there. Another method to classify the manufacturing processes is that we have already discussed in our previous lecture, but here just I am going to remind that one. So we can tell positive manufacturing, we can classify on this basis also: positive manufacturing, negative manufacturing, and we can tell also zero manufacturing. This is also the way through which we can classify the manufacturing processes. What is the meaning of this one? Positive manufacturing means, suppose we are doing the manufacturing process, whatever the manufacturing processes we have chosen to change the dimension of the specimen. If during the process we are adding the material, just like welding, suppose we are using shielded metal arc welding, in that we know we will use the electrode. So two plates, suppose my palm, I am going to weld these two parts, and electrode I am going to use. So this electrode will be deposited on the surface of the metal that we are going to weld. So what is happening in this one? Actually, there is extra deposition of the material. So whatever the weight or the mass was initially of the specimen, after welding, it's not going to be same. In fact, it will increase. That is the reason it is known as positive manufacturing process. So if during process some material we are adding, this one is known as manufacturing process. Positive manufacturing process. So that totally depends. If we are adding the material, it will be positive manufacturing. But second example is machining process. If we are taking machining process, we know here we are removing the material. That is the definition of the machining, actually, removal of excess material. So if you are removing the material, of course, whatever the material was initially, or whatever the weight of the material was initially, it's not going to be same after the completion of the manufacturing process. Definitely it will be less as or what it was at the starting of the process. So that's why it is known as negative manufacturing. Means during process of material we are going to lose. So that will be negative manufacturing. Third one is zero manufacturing. It means before, whatever the weight of the specimen was, after manufacturing or after processing also, it's going to be same. If this is the situation, it is known as zero manufacturing. So in this process come under this category forming. Why this process come under this category? But as we know, here neither we are melting the material nor we are removing the excess material. What actually we are doing? Simply we are applying different type of forces, or a combination of different forces, to simply change the shape and size or dimension of the material. So neither we are adding the material nor we are removing the material during the process. That is the reason it is known as zero manufacturing. So whatever the weight of the specimen was at the starting, it is going to be same after the process also. That's why it is known as zero manufacturing process. Casting more or less also come in this category, because casting, whatever the accessories will be there in the cast product, we know after casting we are going to remove and remelt that one. So if you'll see in that way, in casting also there will be neither loss of the material nor there will be addition of the material during the process. So these two processes, forming process and casting, we can say it will come under this category. This is also one of the way through which we can classify the manufacturing processes. So next we are going to see how to classify the joining processes. The joining processes, as I said, that it can be classified, it may be permanent, it may be semi-permanent, depending upon whether we are able to dismantle the parts without physically damaging or not damaging, depending upon that. Welding comes under permanent joining process. This is permanent. What is the meaning of this one? Permanent means if two parts I have combined together, for example, suppose I have combined both my palm together through a welding process, and if I have to dismantle two parts, means I have to remove my palms away from each other, then I will have to physically damage my palm. Then and only then I can remove. If this is the case, it is known as permanent joining, and welding comes under this category. So in mechanical fastening, they say riveting is semi-permanent. If two parts have been riveted together, I know we can remove those two parts separately by just partially damaging the parts. So basically it is having three parts, three permanent, semi-permanent and temporary. Temporary means we can completely dismantle the parts. This shirt I am wearing, this, I know this scarf has been attached with this one, this part, and this can be easily dismantled. If I will remove the thread through which it has been attached, these two parts, so easily I can remove this one. So this will be actually temporary joining, means without damaging, easily I can remove these two parts. So this is known as temporary. But rivet, as I gave one example, it is semi-permanent, means partially you will have to damage. But if completely we have to damage the part, just like welding, if you have welded two parts, I know without damaging it's not possible to remove those parts. It comes under permanent joining. So it is mechanical fastening, adhesive joining, and then welding. Now these two processes are there. These are special joining processes. If two materials are there, suppose this is one of the plate and this is the another plate. If these two plates I have to join together and both are different, suppose this is a different material and this is a different material, and both are not soluble with each other, means there is no solubility in each other, and it is very difficult to weld. So what we'll have to do, we'll have to bring a third material which is known as the filler. So that filler will come into picture, which filler will be soluble with this one and these two parts that we are going to join together. So when this kind of joining is there, where we are using a filler which is soluble with the first part and also soluble with the second part. First part and second part that we have to weld, those two parts are not soluble with each other. These kind of processes, when there it is, these two processes come into picture. One is known as soldering and one is known as brazing. This name has been given, brazing and soldering, upon their application and also the type of filler being used. So if copper in its alloy we are using as a filler, then it is known as brazing compression, and when tin as a filler we are using, it is known as soldering process. So these are special welding processes which will come into picture when the two materials that we are going to join are different, and not only different, those two materials are not soluble with each other. Then these two processes will come into picture. So this is the classification of the joining processes. But in our syllabus, welding is in detail and we are going to start this. So we'll first classify these welding processes. So welding process, many methods are there through which we can classify the welding processes, and that also depend what is the state of the material during the welding. What I mean by saying a state of the material is, means whether material remain its solid state or it is in liquid state or it is in solid and liquid state. Both states are there simultaneously during the process. So that is the one of way through which we can classify the materials, I mean welding processes. So during welding, if material is changing its state, means initially suppose these two parts we are going to join together, they are in solid state. If during process material is changing its state from solid to liquid, so it is known as liquid state or fusion state welding. So arc welding comes under this category. In all the arc welding processes, some of the examples has been taken here, like a shielded metal arc welding, gas metal arc welding is there, then tungsten arc welding is also there. So all these arc welding processes comes under this category. This category means this will be under the category of fusion welding or liquid welding also. This is known as liquid welding, means during welding material is going to change its state from solid to liquid. Another state is or another type is which is known as solid state. Solid state means here material is not going to change its state, means two plate which are in solid, suppose we are going to weld together, after welding or during welding also it will remain in solid state. It's not going to change its state from solid to liquid or other form of the matter, then it is known as solid state. Example is friction welding. We know that if two parts we are joining, two cylindrical parts we are joining with the help of friction welding, so we know because of the friction heat will be generated. That heat and of course pressure at the last will be used to join the two parts. So here material will be in solid state, it will not be in liquid state, means material state will not change. So friction welding is one of the example. Then explosive welding is the another example which come under the category of solid state welding. And friction stir welding is the another example which also comes under the category of solid state welding. So what is the meaning of solid state welding? Solid state welding means material that we are welding together, it's not going to change its state during the welding, it will remain in solid state. Third one also category is there which is known as solid liquid state. Solid liquid state. So we discussed now this soldering and brazing. This one will come under this category. Why this one will come? Because the filler material that we use to join these two parts which are not soluble with each other, this will be in liquid state, but these two material will remain in solid state. That is the reason the third classification, which is solid liquid, is given for these two processes. So if we will classify material on the basis of the state during the welding, so it will be in three parts, and those three parts are, it will be liquid or the solid state welding, it will be the liquid fusion welding or liquid state welding. Second one will be the solid state welding, where material will be converted into liquid state, so material will remain its form, I mean solid state. And third category is solid liquid. So in this category, soldering and brazing will come. Soldering and brazing. Soldering and brazing will come in this category. The reason is filler will be in liquid state, and the part that we are going to weld together, these two parts will remain in solid state. So this is the one of the criteria. Another criteria is also there, through which or by which we can classify the welding process. That criteria is on the basis of the filler. If we are using filler in a process, or we are not using filler in a process, or if we are using filler, what is the nature of the filler material, whether it is same with the base metal that we are welding or it is different from the base metal, depending upon that also classification is that. So if filler material we are not using, the process is known as homogeneous method. Okay, this is known as homogeneous. Another one, if filler we are using, then it is known as autogeneous. Autogeneous means if filler are not being used during the welding. Many processes are there. For example, suppose we are doing a spot welding. In that, it comes under the category of resistance welding. There will be no filler used. So this kind of processes will be known as autogeneous welding processes. If we are using filler material, I mean electrode we are using to join two parts together, and that electrode or filler that we are using to join two materials is having same nature as the parent metal which we are going to weld, then it is known as homogeneous welding. Example is many examples. Suppose this shielded metal arc welding we are using, and suppose two mild steel pieces we are going to weld together, and the electrode that we are using, it is also made up of mild steel, then it will come under the category of homogeneous. The third category is which is known as heterogeneous. Heterogeneous means here also we are going to use the filler material to weld the two parts together. But what is the difference? the filler that we are going to use, it will be different from the parent metal. Means if mild steel we are using, it's not going to be mild steel. If it's stainless steel we are going to weld together, the filler that we are going to use is not will be a stainless steel, then it is known as heterogeneous. So this is the another way through which we can classify the welding processes. If filler we are using, not using, if we are not using, then it will be autogeneous. If we are using and nature of the filler is same as the parent metal, then it is known as homogeneous. And if the filler nature is different from the parent metal, then it is known as heterogeneous. Okay, so this is the another way of classification of welding process. Now we'll see different type of joints during the welding. When we are joining two materials, so different type of joinings are there. If two parts, just like this my palm, if we are welding, going to weld this one, this is known as butt joining. So this is the one part, this is the another part that we are going to join, and this is the area where we are going to join these two parts. So this is known as butt joining. This configuration is known as butt joining. If one part is overlapping on the another, you can see here, this is the part 1 and this is the part 2 that we are going to join together, and it is overlapping on one part is on the other part, and we are joining here. This part is known as lap welding. Okay, if the joining we are doing in shape that we are going to generate, we are joining here and the shape generated is like T, so this is known as T joining. If at the corner we are joining, this is the one part and this is the another part that we are going to join, and here we are going to join this part, this is known as corner joint. If edge wise we are joining, you can see here, this is the part 1 and this is the part 2 that we are going to join this here. So this part is known as edge joining. So for today's lecture, that's all. We are going to stop here. Next lecture we will start different manufacturing processes one by one, and the last will in this course will of course see what is the weld metallurgy, and of course in detail you see what is the meaning of heat affected zone. So next lecture we will come up with different welding processes one by one, and through this we'll complete all the welding. For today we'll stop here. Thank you.